So let's see how to solve the optimization problems in which we have been asked to find the length and the width of a rectangle that has the parameter of p units and a maximum area. So according to this one, the given equation, the given equation is find the length and the width of a rectangle that has a parameter of p units. So the parameter of the rectangle is given. So let's suppose x is the length and y is the width of a rectangle. So in that case, you will have p equals to, so here x, so on the opposite side it will be x. If on the side is the y, so on opposite parallel side is also y. So parameter means add all the sides. So you have 2x, so it will be 2x, plus you have 2y, so it will be 2y. So the parameter equals to 2x plus 2y. Now the constraint equation is the maximum area. So first of all, write the equation of area, which is length into width, that means x into y. Now from the given equation, solve for either x or for y. So let's suppose I solve for the y equation. So keep the 2y here and bring the 2x on the other side. So it will gives you p minus 2x. And why we have kept this p? Because they says that the parameter is the p units. Now solve for y. So divide the whole equation by the 2. So you will get y equals to p over 2 or 1 over 2p minus x. Now once you are done with this y value, put the value of y in your constraint equation. It means you will write here a equals to x, and in place of y you can write here p over 2 minus x. So p over 2 minus x. Open the bracket. By using the distributive property, you will get a equals to p over 2x minus x times x gives you x square. Now take the derivative of this area. So the derivative of any constant multiplying by x is a constant, so p by 2, minus derivative of x square, you all know, 2x. So you are done with the derivative. Now solve for x. So how you will solve for x? You will set the equation equals to 0. Keep the x over here or bring this x on the other side. So it will gives you positive. So positive 2x equals to p over 2. Divide both sides by 2. So you will get here x equals to p over 4. So now in order to get the value of the y, put this value of x in the equation which you already found. So y equals to p over 2 minus the x is equals to p over 4. Now if you just minus it, half minus half 1 over 4, you will get p over 4. Those who don't know how to do it, let's see, the p is common. So we wrote the p as it is. Now from here we have 1 over 2 minus here we have 1 over 4. So half minus 1/4 will gives you 1/4 p. So this is the value of y. So now you have the value of x and you have the value of y. It means you have the length equals to p over 4 and y equals to means the width equals to p over 4. But you want to check that whether the constraint fulfills your condition or not. So let's see, take the second derivative. So take the second derivative of the area. So you will get a double prime equals to p over 2 is a constant, so it will be 0, negative 2x. So derivative of negative 2x will be negative 2. And you all know that if the second derivative is less than 0, then you always have relative maximum. So that means it has a maximum area at length equals to P over 4 and the width equals to P over 4. Hope you understood this thing.